Hello and welcome. Today on the bench we have something a little bit different. I had a company, SGleds, S-G-L-E-D-S LEDs, offer me a security light for review. And since you can never have enough security lights around the property, I figured what the heck, I'll take them up on their offer. It's a somewhat unusual configuration. Kind of looks a little bit like an alien bug. Now this does come in several versions. The one you see before you here is their 27 watt, which is supposed to replace a 200 watt incandescent unit, and it's 3 and 3. They also have an 18 watt in this configuration where there's 2 LEDs on each side, and that's supposed to replace a 150 watt light. They have this 4 LED version which is 36 watts, and they claim replaces 250 to 300 watts equivalent. Or you can also get the 4 LED in this version, which is probably what I would opt for if I was buying them, because from a distance the 4 LED version is going to look a little bit more like a conventional floodlight. You know, from a quick glance it won't have an unusual appearance. So that square configuration of the 4 LEDs will look a little bit floodlightish, if you will. The listed price for the unit here on the bench is $43 from Amazon Prime. Now you kind of got to take, do you want to spend $43 or $16 plus a couple of bulbs for the incandescent one and be up there every couple of years changing lamps? The 4 LED units are $55 and the 2 LED unit is $35. What was interesting, however, was I also came up with this unit, which is identical from a standpoint of the moldings. I mean, right down to the brake line and the gasket on the passive infrared sensor. It looks virtually identical, with one exception. It has one large LED chip in the middle, and this unit here has got 1, 2, 3, 4, 5, 6, 7, 8 independent little LEDs. Now I'm going to guess there's more than one LED in each chip, but we're going to do some testing and find that out here shortly. It comes, of course, with its instruction manual and the prerequisite gasket. One nice little addition is it's got a plug here to put into the hole where the screw mounts it. Let's see if we can get these out of the way. Get some more light in there. Right down here in the center anyway. Anybody who's put, there we go, now we can see it. Anybody who's put one of these up and then gone back up to service it knows the critters love to move into there. It becomes a bug condo very quickly if it isn't plugged up. Appears to be a fairly robust plastic. Of course, how that would stand up to sub-zero weather is unknown, but hopefully it'll be up and not being touched at that point. A pretty rugged, looks like PVC plastic, I'm going to guess. I don't know, I'm not AVE, and I don't know how to read the plastic codes. Of course, it's made in our favorite country, China. Not that they can't make some good stuff, believe me, they can do it if there's oversight. I kind of like the plastic, actually, because if you put up the metal ones, you know, they've got like the conduit type nut over here so that you can aim these things, and of course every time you aim them the nut loosens up and you tighten the nut, and as you tighten the nut it turns back to the other position. That can drive you crazy when you're up on a ladder trying to aim these things. This one, very firm motion, and it will stay in position. I'll tell you what, even under a heavy snow load, that's not going to move. Also in this direction, it takes a good robust pull on that to move it, and it will stay in position. Plastic on plastic, and I kind of like it, to be honest with you. Same with the PIR, the passive infrared sensor. It has a nice mounting thing, and that will stay in position. Once it's aimed, it's not going to move. but it is easy to aim. It's got the standard controls you'd expect. You have the test function, auto function, full on, so you can control it with your light switch, or what they call full nighttime, when as soon as it gets dark enough, it will come on and stay on all night instead of being using the sensor. You have your range, your time on after it's been triggered, how long it stays on, and one marked Lux, and that one is used to set the sensitivity of the daylight sensor. There's a little photo detector in here, photo cell in there, and depending on where you set this will determine on how dark it has to be before the unit goes active. Now when I looked at this on the internet when they offered it to me, I said, oh wow, big aluminum heat sinks. And then it came here and I looked at it and I said, oh, those are plastic. That's not going to be much of a heat sink. And I rubbed my finger on them. I said, yeah, that's plastic. And then I was reading the description online and it said advanced ceramic heatsink technology. And I said, ceramic? Really? So I went and got a file, a little jeweler's file, and ran it over the edge of one of those, and it just kind of skittered right over the top. Those are indeed ceramic. I was amazed, surprised, and pleased. But those are ceramic heat sinks of some nature. Now, I'm not a ceramics expert, so I don't know how well ceramic dissipates heat, but evidently it works because that's what they've done. Let's see here. Let's see what's inside here. I'm expecting to find some sort of little switching supply or buck regulator. We saved it, didn't go anywhere. And there we have it inside. Let's see what kind of a chip. I'm into Big Clive territory here now. I hope he doesn't get mad at me. It appears to have a conformal coating. It's not real thick, but it's conformally coated, which is good. It's going to keep the humidity out. And the chip, let's see, it looks to be, well, let me look up the number and we'll show you what it is. How's that? Okay, and as expected, it's a constant current LED driver, buck regulator. This is a Bright Power part number. Bright Power is fairly famous, I guess, for making LED power supplies and LED control chips. This is a BP 2867. So, pretty common stuff. What we would say is jelly bean parts. Nothing in here you couldn't replace except the transformer, probably. The transformer is fairly small, but then the unit's not extremely powerful. Let's take a look at the back side of it here. We'll pull this screw out. Of course, always have the right screwdriver for the Phillips screws. Very important. And pretty much what we expected to see. There's our bridge rectifier, full bridge rectifier. We've got a diode here, handful of passives. Normal stuff, and as Big Clive would say, good separation. But I'm curious to see how hard they're driving the LEDs. They're claiming 50,000 hours on the LEDs. Of course, that seems to be the standard on most advertising, but if they're not pushing them too hard, I guess we can expect that. So let's find out. Let's see here. We've got, yes, one pair, boom, boom, and the other pair. Okay. Excuse me. Now that I know how they've wired it up, I will drop this back in here. This was on top. Yeah, this protects. Turn it over. There we go. Put this back in here and we'll take some voltage and current readings and see how hard the LEDs are being pushed. Let me get this screw back in and I'll be right back. And did I mention the back side of the board is also conformally coated, so any moisture or humidity that gets in there hopefully won't have a large effect. Now, of course, none of the terminals are coated, and well, I guess the chip is coated. I can't see, it doesn't look like there's a lot of coating on the leads. of the driver chip, the buck regulator chip. Hopefully the water won't get between the pins and finish that off. But if it's mounted properly and the gasket's working, I think it should be fine. Let me get a power cord over here. And I don't think I mentioned the little bracket that goes across your electrical box to mount the unit to is a whole lot thicker and more rugged. Oh yeah, that's a pretty rugged piece of metal. Half the time when you tighten the screw down to mount these things, these little brackets bend. You even got a place to put the ground wire if you don't have access to the ground wire separate in the box. If it's just grounded to the box itself, this will ground your light. Of course, it's fully double insulated in plastic. It's interesting to see a ground on it. And that could be for noise suppression, I suppose. But I'm not going to go full Clive on this and rip the LED sections apart, because I want to test this outside and see what kind of light, or how the light compares. We'll hook up to our Wago clone here. These are a Chinese clone of the Wago connectors. I've worked with Wago connectors in industrial equipment for many years and absolutely love Wago connectors, and these aren't a bad copy, to be honest. Okay, let's plug this puppy in, turn it on, there we go, and there, light came on. We will put this in, probably swamping the camera out at this point. I am going to put this in full on mode so that it stays on while we're doing this testing. And let's find out what kind of voltage they're putting across the LEDs to begin with. That'll give me some idea of how this is wired. I'm assuming it's series strings inside each LED unit and parallel units, but let's find out. Well, why did that shut off? That should have stayed on. Oh, that's auto mode, on time. Okay, I went to the wrong selection here. That should stay on. There we go. And we get everything in frame. There we go. We got our voltmeter, measure volts DC, enter, okay. And let's go in here and find out. Alright, 68 volts, 68.5 volts, we'll call it, across the LEDs. So let me briefly shut this off and we'll do the maths, as Big Clive says. We've got 8 times 3, that'd be 24. If these are single chip. I am guessing there's multiple chips, but we'll do some more tests and we'll find out here. It won't be very difficult to figure out. On, so what did I say it was? I've forgotten already what the voltage was. 68 volts, 68.5 volts, I think. 68.5. And we'll divide that by 24. Okay, so that works out to 2.8 volts per chip, which is to be expected. The white LEDs typically take somewhere between 2.7 and 3 volts to turn on. And I'm guessing, again, like I say, I'm guessing there's going to be 3 chips in each of these. I don't think they're running them in series completely. I can look in here and I can see that this is a series ring, this is a series ring, and this is a series ring. But let's do a couple more tests and see what we've got. Let me get set up to test the current. Okay, I have the meter set up to measure amperes. Now this is designed to use a current probe, and it actually is measuring a voltage and converting it to amps internally. But I'm using a precision shunt here. This is an accuracy supposedly of 0.1 of 1%, is the way it's listed on here. Sensitive research. I picked up a bunch of these shunts from a local supply place, surplus supply place, when they were in business. They sadly went, well, not out of business, but they sadly closed the store while I was setting up housekeeping in Asia. last year. They still have an online presence, ESS, Electronic Surplus Services. I used to love going in there. I got a deal on a whole bunch of different ranges of these current shunts while I was in there one afternoon. At any rate, that's neither here nor there. Let's see what kind of current they're running through the LEDs. And turned on here, and this says 160 milliamperes, 0.16 amps. Now, 0.17. It takes a little while for this meter to settle down, and it's not because this is heating up. This will handle many amps before it starts to heat up. So 0.17, and to be honest, I measured this with another VOM earlier, and it was 175 milliamperes. So you see it's jumping between 160 and 170. I'm using this because it's easy to read on screen. So let's call it 170 milliamperes. That appears to be what it's pretty much settled down to. Now, I'm going to shut this. Oh, no. I am going to swing over here briefly. This was supposed to be a 25 or 27 watt, and it's reading 24.7 watts. We'll call it 25 watts. So, fair enough. I think that's close enough to their claimed 27 to be legitimate. I'm very happy with that reading. I'm going to shut this off for a minute, and we'll move back over here. Now, as I said, I suspect there is more than one LED in each of these, because if you went excuse me, 3 times 8, you'd have 24 chips in each one of these, which would still equal our 68.5 or 69 volts that we're seeing across the power supply. And I don't believe they're running, because these are barely even warm. I can't believe they're running 170 milliamperes through these LEDs. They wouldn't have a very long life unless they had some serious aluminum heat, large aluminum heat sink behind them, and were cooled. I'm guessing there's 3 chips in each of these, and that's totaling up to our same 24 that we have, 3 times 8, 24, or 8 chips times 3 internally is 24. It's going to be the same voltage, and that means the current would be divided by these. And okay, let me clear this calculator here. Come on, clear everything. There we go. So 170 milliamperes, 0.17 amperes, divided by 3. That would be 56 milliamperes per string, which is a whole lot nicer than 170 milliamperes per string, which would be what it is if they were all in series and single chips. I'm guessing, again, 8 times 3, 24 chips in each one, and these are in parallel and sharing the current. So I'm guessing it's going to be 56 milliamperes per unit. We're going to prove that, or disprove it. Okay, I have wired up one of the strings to a bench power supply, and we're going to slowly bring the current, or the voltage, up until we reach the point where the LEDs will turn on, approximately 68 volts. I have limited the current to 10 milliamperes because we don't want them bright. We just want them on enough to see what is in each chip. And there they came up. Can you see that in the camera? Boy, the camera's a lot more sensitive than my eyes are. I'm going to bring them up so that I can count how many chips are in each LED segment here. If I can get around. Oh yes, there are 3. There are definitely 3 chips. You should be able to, I hope, see that. If it isn't washed out in the camera, let me turn it back down. You should be able to see 3 chips. I really can't tell looking in the viewfinder here. but there's 3 individual LEDs on each chip. So sure enough, there's 24 LEDs in a series string in each one of these modules. So they're running the 3 modules in parallel and sharing the current between them. So that gives me confidence that the LEDs are going to have a fairly decent life. I'm just going to go through a range here because I don't know how well the camera's picking it up. Okay, there's off. I can see it go off in the viewfinder. I can see light in the viewfinder, so I'm assuming you can see the 3 chips. I've got the camera about an inch away from the, or the lens about an inch away from the LEDs. So I can't get my head in there to see them, and I'm trying to look through a tiny little 1.5 or 1 3/4 wide viewfinder here. So there we've proved it anyway. There's 3 LEDs in series in each one of those LED chips, if you will, or chunks, or whatever you want to call them, substrates. There's our 68 volts each. One more test I want to do before we go outside and compare this to an incandescent. We're warming up the spectrum analyzer because, being a ham radio operator, I am concerned about RF noise coming out of anything LED, especially when it's from Asia. But we'll find out. Now, I was lamenting a second ago about ESS, my favorite online store, no longer being available to walk in and peruse. Over the years, I have collected much of my test equipment. This power supply right here, which will give me 20 amps up to 24 volts. This dual power supply, which is up to 60 volts, 5 amps times 2 dual power supply. The dual power supply that's hiding in the background here that I just used to power up the LEDs, that came from ESS. These 2 voltmeters both came from ESS. And this is a 4-wire meter, extremely accurate meter. This triple power supply came from ESS. The distortion analyzer came from ESS. Over the years, many things. Oh, up here we have a pulse generator. That came from ESS. One of these 2 signal generators, the bottom one, that came from ESS, as did this very precise Hewlett-Packard digital voltmeter down here. This came from ESS, and I don't think the noise analyzer did, but that precision digital voltmeter came from there. Over the years, I've many other pieces of equipment which I have passed on since have come from that store. I'd walk in there and see something that was much better than what I owned, and they had a policy: if it didn't work correctly, they'd take it back. And I think over the years, I never took, if I took anything back, it wasn't more than 1 item. Let's put it that way. I can't think of anything I ever purchased there that wasn't correct, because they'd run it through tests and make sure that it functioned, and then I would just verify calibration. At any rate, I'm going to hook this up, turn on the spectrum analyzer, and see what the results are. Okay, I order tons of stuff from Amazon. I just have to include this in the video. I ordered 8 sets of SMA to F type connectors, both in male and female configurations, for setting up different tests and so on and so forth. This is what they sent me: BNC to video balun. 8 sets of these. Fortunately, returns are free and they'll take care of it, but somebody back at the warehouse made an oopsie. Okay, Amazon junk returned. I shouldn't say Amazon junk. Amazon mistaken order has been returned. It's not costing me anything to send stuff back. I have Amazon Prime. It's just I got to stop what I'm doing, put everything in a box, and bring it back. A little bit annoying, but it's the first time I think they've got an order wrong, so I will forgive them. Alright, the unit's fired up, the spectrum analyzer's fired up, and I have my favorite HF noise detector with me. Now, I'm going to turn this thing on. That's my overhead light. I'm going to shut that off. I'm going to shut off the fluorescents. In fact, I'll shut off all the fluorescents that are in here. That's the overhead fluorescent. Now, I'm sure the camera's washed out at this point. However, if we can see anything, I'm going to get real close to this. I've got to get pretty much on top of the unit. It appears to be mostly from the switching supply, but here's the interesting part. I don't know if you can see this. Here's the power cord. The power cord's silent. It isn't until I get right next to the switcher itself. And that actually makes me feel pretty good, because where I have most of my security lights are on the barn, and my 160 meter antenna runs the length of the barn over the top of it, and if I have noisy lights out there on low band, I'm going to have a real problem. So from what I'm seeing, it's a lot quieter than my interior lighting is at this point. So I'd feel pretty comfortable about putting this up on the end of the barn, on the backside in particular, and not be too worried about causing problems. Now, I'm going to turn on the other camera here. There is some noise on this unit, and as soon as I get this camera fired up, come on, turn on, there we go. Get the lens cap off, dummy. Alright, now I've got to set up the spectrum analyzer correctly here, because right now it's on a 2 gigahertz or 3 gigahertz span, excuse me, 2.9 gigahertz span. So let me make some changes to the spectrum. Okay, we have a 230 megahertz center frequency and a 460 megahertz span at this point. Now I'm going to shut the unit off, and you can see that all of that goes away. So we do have noise, it appears, in the VHF spectrum at least. Let's put a marker up here and see where everything is. There's our first real peak right there. That's at 76 megahertz. The next one's at 137 megahertz. And 204.7, and where's this one? Roughly 245. And this last peak is 394. Now our biggest offender right here, it says minus 50. Now this is not calibrated anyway. This is just picking up what's coming out. If I get closer, they're going to get bigger. Right now I'm right on top of the spectrum analyzer. If I move away, let's see, that's about 2 feet. There's about 3 feet down the bench from the spectrum analyzer. Here's the power cord. You can see there's some broadband noise, but nothing really horrible. That doesn't worry me too much, because my VHF antennas are up at about 85 feet in the air, so I don't think that's going to give me a problem if I put this thing up in the back of the barn. And my biggest spike now is still on 245 megahertz. There's 220. So if you're trying to operate the 220 low weak signal work, you might be a little bit worried about this right here. But I don't know anybody doing 220 weak signal work. I know they're out there, but I don't think there's a lot of guys doing it these days. All in all, I'd say from an RF standpoint, it's better than my interior lighting, and I consider most of my interior lighting not too bad. I do turn off a lot of stuff when I'm operating, but it doesn't seem to make much difference to my noise floor here. One more thing, whoops, I'm not going to shut that off. One more thing I'm going to do is I am going to take, now that this has been on for a couple minutes, let's take some temperature readings and see what things look like. I don't know how well this is going to work. This is the first time I've tried this. I don't know if I'm going to be able to show this while I'm doing it or not. I'll have to turn the camera over here and we'll take a look with my Seek. This is my little Seek thermal camera, connects to my phone. And let's see, the chip is running at 60C. I don't know if you can see that. The little buck boost transformer here is 58C. Capacitor's 28, that's pretty cool. 41C down here. That could be the bridge rectifier underneath the board, I don't know. But those items don't appear to be overly hot. I'm comfortable with those numbers. I'm going to take a reading on the LEDs themselves. This is going to be a little tricky, but let's see what we get here. Let's see. Try to get it right on one of the LEDs. 54C, that's pretty reasonable. 56C. 54C. That's actually not bad at all. That's they're warm to the touch. I can put my finger on them. Yeah, I'm perfectly happy with those temperatures. That's very reasonable. Okay, this is a bit of a redo because I realized that the camera wasn't seeing the LEDs. It was actually seeing the heat sinks. So we'll try this again, and we'll get the camera in here. These are the heat sinks, and that's 59, 60. Let's take a look at the next one here. 61. I've seen some of the heat sinks at 64. They're pretty warm to the touch. There we go. There's 64. Which again, you know, I'm not going to worry until it's getting up to 80, 90 degrees, and at 64 they should be okay. Would I like them cool? There's 66 on that one right there, 66C. Looking at the LEDs themselves, they look pretty cool, and it may just be that the plastic does not transmit the IR. And in fact, I would bet that's the case. We're not able to see the LEDs at all because that plastic is probably opaque to IR, and what you're seeing there is just the surface temperature of the plastic out in free space, free air. But this has been on for, you know, quite a while now, and it doesn't appear to be going much above 64C on the heat sinks. And you can probably hear this thing calibrate. I'm going to bring it up to the camera here. Hear that click? This thing self-calibrates every few seconds. I don't know what the true accuracy of these little Seek cameras are, but I've heard good things about them, and it seems to work well. I have measured stuff with an actual thermocouple, and they're within a degree or so, so I'm comfortable that it's doing its job. And now that I'm right close to the spectrum analyzer, the noises come up, but as we saw, when I got like 3 feet away, everything was fine, or pretty well suppressed. And again, there doesn't appear to be anything on the power cord emanating from the power cord. It all appears to be within the unit, so it won't be broadcasting through your house wiring. That's pretty decent. All in all, I'm pretty impressed with this unit. And again, you guys know me. If I didn't like this thing, I'd be tearing it to bits. You've seen me do that with other items. I'm not afraid to speak my mind, as the trolls are wont to let me know. And I don't mind. That's absolutely fine. Everybody's got their opinions. Alright, I guess what I have to do now is wait for darkness. And when it gets dark outside, I'm going to mount this and a couple of par 38s next to them. Now, it won't be an extremely fair comparison for a couple of reasons. These are 5000K lights, and to be honest, That's one thing I don't like about these. I don't like those intense white, blue-white daylight temperatures. It's hard on my eyes. Where I would put this out behind the back of the barn, it'd be fine for lighting up the woods and the ramp. I got no problem with it out there. I much prefer, however, tungsten 2700K. And the only thing I've got to compare this to, this is, you know, they say this replaces a 200 watt lamp. I have about 160 watts of quartz halogen par 38 lamps. I have one that's 120 and one that's 39. 40, so 160 watts worth roughly of par 38 quartz halogen, which is as close I can get to matching the color temperature. If I was to do it with basic incandescents, they'd be so yellow that the test would just totally be useless. So as soon as it gets dark a little bit, I'm going to go out. I'm going to mount it. I'm going to get these all set up and mounted outside at the same height above the door like I would have normal lighting. And as soon as it's dark enough, I will lock the aperture, or not the aperture, I will lock the aperture. I will lock the aperture on the camera and the shutter speed, and we will try to do an A to B comparison on how well these things cast light out in the backyard here. So we'll be back with you. For you it'll be seconds. For me it's going to be several hours. This is the par 38 quartz halogens shining up into the backyard on the grass, and you can see the trees up there. I'll aim this up a little bit, and I'm going to switch over now to the LED lights. And the barn appears to be a little bit brighter. They're not throwing as much light up to the woods as the par 38s do, but they certainly brighten up the close-in objects a little bit better. It certainly makes the grass green. I'm going to switch back here. Yeah, they certainly make the grass. This is back to the par 38s. And you can see the trees up in the background stand out a little better. Now I've tried to aim these exactly the same spot as close as I could. It's pretty hard because the par 38s are flood lights, and I aim them at the center of the grass, pretty much where you see that hot spot. The barn certainly doesn't light up as well. The other ones certainly scatter the lights around better. And there's the LED again. I guess I'm going to have to say the LED is a clear winner on this one, even with the white daylight light. In fact, it doesn't look so bad out here at night. I don't like them in the house, but I think I might be sold on them for out here. Certainly a much more even light. And there you have it. There's your SGled's 27 watt security light, and I think I like it. So I might just put that one up on the end of the barn, on the back side up here where the ramp is. It certainly will light up a lot better than the par 38s I have out back right now. Your choice. I'm the Radio Mechanic. See you soon, and thanks for stopping by.